Hello, my name is James Jones. I'm with GAMA. I've been there for about 27, 28 years now, different job functions. I've worked in our lab and installed booths. I've not been here to SurTech before, but I've traveled a lot and been to a lot of our customers. Most of my background is customer service, tech service. If you call in on the 800 number, it may be me that answers the phone. So we're going to go over the training class. This is our application and maintenance class. And we do this class 3 or 4 times a year in GAMA in Indianapolis. It's usually a 2-day class. We're going to condense it down to 1 day today. So the agenda is usually we'll go over a little bit of theory of powder coating, safety, some terminology, and then get into the equipment, going over manual guns, automatic guns, the spray booth, dust recovery, the ancillary equipment such as the gun movers and hoppers in the sieve. So it's a little bit of an open format. If you do have any questions as we go, feel free to ask, and then we'll have a question and answer session a little bit later on. So I'll get started here with electrostatic principles. Basically, I think maybe half of you have done powder coating before in here. Some have not, so some of you this is old news, some of you it's probably brand new. With electricity, people think of electrostatics with these guns because it's electrostatic spray equipment. Truth is we use very little electricity. We use a lot of compressed air. And most of your issues that you'll run into are probably compressed air issues more than the electrostatics. But I'll explain to you electrostatic deposition, or how we're getting powder to apply to a part using electricity. Electricity generally seeks a balance. So if something is highly charged and then something else nearby is at a lower charge, that charge will move to try to balance out. So we use terminology such as voltage. Voltage is just potential, electrical potential. If you look it up in the dictionary, that's what it'll tell you. It's a measurement of how much potential energy you have. And then the current is a measurement of how much of charge is moving or flowing. So what we're doing is we're charging up a needle at the front of the gun up to 100,000 volts of static charge. Static is stationary. It doesn't flow like electricity in a wire. It kind of builds up and it jumps or flows to find something at a lower potential. So if you use that high of a potential, you can get it to move. The current, though, is very small, microamps, millionths of an amp. So there's not a lot of power there. If you work around these guns a lot, you may actually get shocked by them. Has anyone been shocked? I see some hands going up. Well, this shock, although it's not pleasant, it's generally not the kind of shock that's going to burn you or send you to the hospital like an electrocution. It's static. It zaps you. It's like walking across the carpet and touching a doorknob, except it doesn't necessarily stop until you release the trigger or get away from it. You're getting shocked because you're not grounded. This gun's putting out all this charge. It's going to you because you're at a lower potential. So it's seeking ground, which is 0 volts or no potential, or anything at a much lower potential than the output of the gun. So electricity will move if it can overcome the resistance in between, so it's going to flow much easier when it's closer to a ground. If you put the gun up close to the part, you're going to get more current. And guess what? When you start drawing a higher current, the voltage will actually go down because you're realizing that potential. So it's going away. On our gun control unit, if you set it at 100 kV, doesn't mean you're going to get 100 kV. You get up to 100 kV. The same thing with the current. It's a limit. You set that current setting, you can get up to that amount, but it doesn't necessarily mean you're going to get what you set it at. There's an inverse relationship. The higher the voltage, the lower the current. Once you start realizing that voltage, that potential, it goes down, the current will go up because that charge is being moved to ground.